Okay, so this is a video explaining a lot of the naming kind of confusion or misconceptions or things like that. So we're going to go through and break it down. Now then, the easiest naming is just something like sodium chloride. So this is under the assumption that you can name compounds that don't have exceptions. So what we're going to talk about are Roman numerals, polyatomic ions, and then specifically rules for polyatomic ions. Now, to be clear, whenever you are naming something, there is a name change that happens to the last thing. So if I did have NaCl, sodium, the first thing does not get a name change, so sodium stays sodium, but the second thing does get a name change. It's the anion, and it's going to go to ide, so chlorine goes to chloride. So that is our normal, typical name change, and that's how you name normal compounds. Now then, everybody good with that? Everybody can see that? Okay, there is metals with two charges though. And so in that instance, I can't just say chromium oxide. So that's the example I have behind me because it has multiple charges. And those both exist in the real world. There's chromium that bonds and it gives up 3 electrons, and there's chromium that gives up 2 electrons. And so it gets a +2 or a +3 charge, just depending on how many electrons it gives up. And depending on how it's reacting, it can give up different amounts. And so we don't necessarily know just by saying chromium oxide which one it is. And so for example, behind me I have 2 different formulas. So this is chromium oxide and this is chromium oxide. And so if I were to say something like, hey, write the formula for chromium oxide. If you were well versed and you knew that it had 2 charges, you wouldn't know which one to do. And so that's not a proper name. Sodium chloride's a proper name because sodium only has 1 charge and chlorine only has 1 charge. And so there's no confusion. But chromium has 2. And so because of that, we just have to say the charge in the name. And when we do that, we use Roman numerals. And so then you have to calculate which one it is. And so whenever you're calculating, you always have to base it off of the negative charge because oxygen doesn't change. Chromium is the thing that has 2 charges. Chromium's the thing I'm not sure about. Is this chromium +2 or is it chromium +3? I don't know, but I can look at oxygen. Oxygen helps me figure it out. And so you have to break it down. So we know oxygen has a -2 charge. And if I have 3 total of them, then I have a total of a -6 charge. I have 2 chromiums, and those 2 chromiums have to cancel out that -6 charge, so they have to be +6. So that means that each of them have to be +3. And you could do the same thing over here. This oxygen has to be -2, and this chromium has to be +2. So this guy's chromium 3, and this guy's chromium 2. Okay, we're looking at the charges. So this guy's chromium 3, and this guy's chromium 2. So to be able to do the Roman numerals, you have to understand how to calculate the charge. Also, if you're really struggling with that, you could just look at the 2 charges, so you know chromium's +2 or +3, combine them with oxygen and see which formula you get. That's a different way that you could do it. I think this way, working backwards, is easier and faster and less guessing and more a standard set of how to get there. But that being said, how you're gonna get there is you're gonna start with your negative charge, whatever your negative charge is, and figure out how many total you have in your total negative charge, and then you know your total positive charge has to cancel out. So now that you know the names of them, or now that you know the charge, you can name them. So again, this isn't just chromium oxide, because if it was just chromium oxide, you don't know which one I'm talking about. And if I were to tell you in a lab, hey, go grab chromium oxide, or on a quiz, write the formula for chromium oxide, you wouldn't know which one to write, and you could get it wrong or you could get it right, and you could just be a good guesser. But we don't like to guess in chemistry because that's when accidents happen, right? And so whenever we're doing this, to write it, I have to do Roman numeral 3 to show that it has a +3 charge. And this one would be chromium 2 oxide. Okay, but you have to use the Roman numeral. The same thing can be said whenever we're going from the name to the formula, but that one makes it a little bit easier because just like I know that chromium 3 means that Cr +3, I can just work backwards, right? So if I had something like iron 2 chloride, what this is telling me that it's iron, which is Fe, And then this is telling me the charge of iron, because that means iron has multiple charges, and in this specific bond, it's a +2. In the next bond, it could be +3, but in this bond, it's +2. And then chlor-I would be chlorine, and so then I just have to get my charges to cancel. But the Roman numeral is just telling you your charge of your metal. So that's how you go back and forth, so hopefully that helps the kiddos out who are confused about that. And then we have polyatomic ions next. So polyatomic ions, we have the simple polyatomic ions, which won't get a name change, they just look funny. And so that's gonna be whenever you have multiple elements. So whenever you see something like this, okay, I see sodium, and then I see a group of non-metals. A group of non-metals. So there's more than one non-metal. That means it's a polyatomic ion. So I can break them apart. I know sodium is always +1. I can go look at the periodic table, find sodium, it's +1. This guy's polyatomic ion, and so it's NO3, and it has to be a -1 because they're 1-to-1 ratios. So my polyatomic ion is this. So when I'm naming it, I do the same thing I always do. So sodium is just sodium. It stays sodium. It doesn't change from sodium, just like in the previous example. Sodium, sodium. It doesn't have 2 charges, so I don't have to worry about Roman numerals. Okay, and then NO3, all I have to do is go look at my polyatomic ion sheet. And when I look at my polyatomic ion sheet, I can see that NO3 is nitrate. Okay, and so that's not a name change. That's not a name change. That's just recognizing polyatomic ions and looking them up. So when you see 3 or more elements in a formula, it's a dead giveaway that it's a polyatomic ion, and you should go look at your polyatomic ion sheet. Now then, I could also have something like this. So this was, we have, move it up a little, sodium nitrate, but I could have this NaNO2, and this is where we're gonna have to apply the rules, which wouldn't really be a name change, but it feels like a name change. If you look, these 2 formulas are not the same, okay? They both start out with sodium, so I name them the same. I can see that they both have polyatomic ions because there is a group of atoms, okay? Group of non-metals together. There's 3 total elements in this problem, but this one doesn't look like NO3. This one's NO3. Whoops, my 3 is gonna be high. NO3, and this one says NO2. I know this one's nitrate, so whenever I see something that looks really, really similar to a polyatomic ion, but it's not the one that's on my sheet, it looks so similar, it's only missing an oxygen or an extra oxygen, or it has a hydrogen or something like that, that means it's one of the rules. And the rules are in the middle of your polyatomic ion sheet. They're 1 through 5. So you need to go look at your rules and figure out which one it is. So right here, when I look at this, the difference, NO3 and NO2, is 1 oxygen difference. It's subtracting oxygen here. Do y'all see that? So I'm gonna look at my polyatomic ion sheet, and I'm gonna notice that I'm in the 8 form. Okay, you're always gonna start with the 8 form. So go look and find your 8 on your polyatomic ion sheet, and compare it to the one in the formula and say, does it have more hydrogens, or does it have more oxygens, or does it have less oxygens? And then you're gonna name it that way. So I'm gonna look at my 8 form, 1 less oxygen than my 8 form, and it says it's the ite form. So this would be nitrite, okay? And that is rule number 4 on that polyatomic ion sheet. And so you just have to look and apply the rules. Your quiz and your test don't have a ton of them, so if you don't get that, just try your best. It's not gonna make you fail. It's just, you may not get 100. So hopefully that's helpful, and good luck today.